Hello, I'm Valentine and I'm going to talk about Flask SocketIO load balancing. Before I dive deep, let me say a bit about myself. I'm based in Harare, Zimbabwe, and I'm a software developer well versed in Python Flask as well as Java Spring Boot. Sometimes I do DevOps tasks using Docker and Git. I usually manage my data using Mongo, MySQL, and Redis. Our key terms today are SocketIO and load balancing. SocketIO is a library that enables bidirectional and event-based communications between a server and clients. Bidirectional, we mean a client can initiate a communication to the server, and also a server can initiate a communication to the clients, and these communications will be in the form of events. Load balancing is a distribution of network traffic among multiple servers to improve a service performance. In our particular case, we have multiple Flask API instances handling our SocketIO events. So let me show you the structure of our system. So this is the structure of our system today. But before we discuss in detail about this whole system, let us talk a bit about basic SocketIO. So basically, SocketIO, we have a client and a server. So in our case, this will be our, let's say this will be our Flask server, this instance one only. Let's ignore load balancer and other instances as well as Redis queue. So here we have client 1, client 2, and our Flask API or Flask server. So SocketIO, this client 1 will connect to this Flask server, and this connection will last for a very long time. Same as if client 2 connects to this Flask server, this connection will also last for a very long time. Ideally, we can say it will be permanent. It will be a permanent connection, right? So once there are permanent connections between client 1 and our Flask server and client 2 and our Flask server, when client 1 emits an event, this Flask server will receive that event. And also, if this Flask server emits an event, this client will also receive that event if it is listening to that event. And also it goes for the client 2, right? So meaning if client 2 sends a message to our Flask server receives the message, and the Flask server sends a message to its client. Client 1 can receive that message, and client 2 can also receive that message. That is a basic SocketIO structure, right? But when we want to do our load balancing, right, meaning that Flask API will have multiple instances, same logic, same Flask logic, but running on different instances, and our different instances are running on different Docker containers, right? So meaning we have this instance 1, it's a Docker container. This is also a Docker container, and this is also a Docker container. But they are all riding on the same Flask application or Flask API, right? And for our or for our load balancer to work, we need to have a load balancer. And the purpose of this load balancer, right, is to forward the requests or the events from our clients to respective instances, right? So let's say client 1 sends or emits an event. This event will be forwarded to instance 1. Or let's say client 1 is requesting to connect to our server or our service or our servers. Load balancer will initiate a connection between client 1 and instance 1, right? And if client 2 requests to connect to a server, the load balancer will connect to this instance, right? So here we have a case where client 1 is connected to instance 1 and client 2 is connected to instance 2, right? So for now, let's ignore the purpose of our Redis queue. So here the challenge with this client 1 connected to instance 1 and client 2 connected to instance 2 is that instance 1 only knows this connection to client 1 and instance 2 only knows this connection to client 2, meaning if client 1 emits an event, only instance 1 will receive that event, not instance 2 or instance 3, right? Same as if client 2 emits an event, right, to instance 2, only this instance will know about this event, not instance 1 or instance 3, since the connection is between client 2 and instance 2, right? So this will raise an issue that if client 2 is willing to communicate with client 1, client 2 will send a message, then load balance or forward that message to instance 2, but instance 2 cannot forward that message back to client 1 since there is no connection between client 1 and instance 2, right? So that is the purpose of our Redis queue now, meaning the messages from these instances will first go to our Redis queue, and this Redis queue will broadcast that message to all these instances 1, 2, and 3, meaning if client 1 sends a message, that message Nginx forwards that message to instance 1, instance 1 will forward that message to our Redis queue, and our Redis queue will forward, or not forward per se, but will broadcast that message to all these instances, meaning client 1 message will be broadcasted to instance 1, instance 2, and instance 3, and that message can now, once it is in instance 2, it can be emitted to client 2, and that is the purpose of our Redis queue. So to demonstrate this whole process I was talking about, I will first deploy a Flask, our Flask API without Redis. Ensure that if our clients are connected to different instances, each client will not receive a message from another client. Then after that, I will deploy our Flask API with the Redis component, ensure that even if our clients are connected to different instances, they can still talk to each other, right? So this is my source code, right? And this is the initialization of our SocketIO server. And as you see, there is nothing mentioned about Redis here, meaning if I deploy our application here, initializing it without Redis queue, there is no Redis component. So let me deploy our Flask server. So this is the command I'm using to deploy our application, right? Using Docker Compose, right? Then this one is telling it to run 3 instances of the same application, right? That's where the load balancing comes in. Right. Our Flask API is now started. You see there is this API 1, API 2, and API 3. There's also the engineers component in this process. It was also started here, and the Redis was also started, but in our Flask, we didn't mention anything about Redis, right? So let me try to communicate with our server, right? So these are my clients. This is a client. This is also a client. So let's assume this is client 1 and this is client 2, right? And let's say our client 1 is called like dark child, right? We say connected as dark child 1. This is the Docker container ID, meaning this is the address where this client is connected to, right? So if I come to our and see if we have a container with that ID, what is the ID? Ending with the 6FD. Let's say in our Flask containers, right? This is the container, right? Container ID 6FT. So our client 1 named Jackchild is connected to this container. Let's try to connect our second client to our server, right? So we can call it maybe champion boy. Okay, so these two are connected to the same container. So if this is the case where these both are connected to the same container, they can talk to each other even there is no Redis, since they are all both using the same Flask instance, right? Because our Flask instance knows all both of our clients, right? So let's say Jack Child wants to talk to our champion boy, right? Okay. You can see, right, in Jack's history, there's the message he or she sends, and also on the champion boy side, this message was received, meaning these clients can still talk to each other since they are connected to the same server or same instance. But let us try to connect these servers to these clients to different instances, right? Now connected to same server again. Let's try again. Oh, same server. Right. So as you see now, our second client is connected to a different instance to the first client, right? This is the address of the second server or instance, and this is another one. So here, when I send or also send a message now, say hello champ, you see that only this sender is receiving the message and champion boy is not receiving the message because these are not connected to the same instance, so they cannot talk to each other, right? So now I want to include our Redis component so that even these clients are connecting to different instances, they can still talk to each other, right? So comment this and comment this. So as you see, now we included message queue Redis, and this is the address of our Redis container, right? Flask SocketIO load balancing Redis and the port number. So if we go to our Docker Compose, this is our Redis service, Flask SocketIO load balancing Redis with this port number, right? So let's try to deploy or run our API again, now with Redis components. Right. Now our server is up and running. So let's try to reconnect our clients again to the server. Okay, this is the child connected to this. Okay, let's see champion connected the same server again. Okay, let's retry again. So now, right, I'm trying to reconnect so that maybe the other client can connect to a different instance to the first one. Because as you see, it keeps connecting to the same server as client one, and I wanted to connect to a different instance, right? So let me try to connect again. Right. As you see now, this instance is different from this instance. So let's see if these two can talk to each other, right? Right. Now, that child can talk to champion, right? You see, I champ from dark side and yeah, from champion boy. See his history. Yes, I champ. Let's see if champ can talk to dark. Okay, you can see they can both talk to each other. Right. So this is the demonstration of our Flask SocketIO load balancing, where if you have any questions or you want to get in touch with me, you can find me on LinkedIn, and my name is Valentine S. Chanengeta. On X, you can find me at Valentine Sean 22. On Dev Community, you can find me as Valentine Sean Chanengeta. Right? Okay, thank you.